Hello, this is Peter Reedy, and today I will be presenting to you the virtual roll call system. On my team, I have Frank Vincent and Peter Reedy. We were the two developers who worked on this product. Major Jason Cohen of the Pinecrest Police Department, who was the product owner and the man who came up with the idea for the project, and our instructor, Professor Masood Sajadi. Problems with the current system. Currently, the roll call system requires that officers be in a physical meeting in the morning, or not just the morning, whenever their shift begins, where the officers are presented information by a supervisor who just stands at a podium and presents the officers with information, just reading off the documents and important things for the day, such as bolos, watch orders, or something like the message from the chief. Officers, however, may not always be able to attend the meeting. For example, an officer might have like an overlapping shift assignment where they have to stay and continue aiding the citizens. They could be attending a court date, or they could have to leave before the meeting is done or even held due to the high call volume. Officers who miss the meeting are often deprived of information and must receive it through secondhand sources, such as another officer, or they can ask their supervisor to get the documents and read over it later, which consumes not only the officer's time, but also the time of those he is asking for help. Here we have the project management schedule. So beginning on the first day, we started with requirements elicitation and everything, and then throughout the semester we worked on what needed to be done, and we managed the dependencies so that we can continue working no matter what. The requirements. The user stories that we have implemented include the login logout, which is also the account system, which allows users to log into an appropriate account where they have the proper permissions. The account creation user story, where a user can create new accounts if he is an administrator. The tabbed view, where as an officer, the user can view uploaded files assigned by their supervisor. Task history. As an officer, a user can view uploaded files from the previous days in case they missed either the meeting or just missed work overall, and they can catch up. Pinning tasks. As a supervisor, a user can pin a task to move it to the top of an officer's view so that they know it's either important and they should probably be aware of it. It does not get archived or deleted like regular non-pinned tasks because of its importance, and it stays pinned to the top of the officer's list until a supervisor removes it. Task assignment. As a supervisor, a user can distribute tasks to officers based on their shifts. So this is the uploading of files and documents that allows the supervisors to distribute it to the individuals. It involves uploading and assigning metadata to the files. Category creation. As an administrator, they should be able to create new categories to the ones that already exist. The ones that exist by default coming with virtual roll call include BOLO, message from the chief, training, and watch orders. Let's see, some more user stories, or the preview of the task assignment where the supervisor can see like what he just uploaded and the information that's associated with it to make sure he did everything correct. Account modification, where the administrator can edit a user in case of like a change of shift or the loss of a password. And the last implemented user story is the user monitoring user story, where a administrator can monitor the activity of the other users within the website. For example, when the administrator wants to know who's online at that time, he can check, or there are also logs saying how long each officer viewed which document, so they can make sure that an officer is actually viewing the documents instead of just logging on and logging off. The use case diagram. Here are all the use cases which we were planning to implement. These are the implemented use cases that we did implement. As you can see, we have three actors where it's a hierarchical, where and a supervisor can do anything an officer can do, and an administrator can do anything a supervisor can do. So therefore, the administrator has permissions of all three actors. Here's some sequence diagrams. I will spend 10 seconds on each so that you can look. Here's the login sequence diagram. Here's the registration sequence diagram, or the creating of a new user. Here's the viewing registered users, all the users that have been created. Here is the editing of user information, where you can say change the shift. Here's the deletion of a user. Here is the idle logout, where if a user just logs in and does not have any activity, they are logged out automatically. Here's the adding of a document sequence, the uploading of the files, and uploading of the metadata. Here is the getting of the categories for dynamic generation. Here is document retrieval. Here is the displaying of the document, either the PDFs or the videos. Here's the creation of a new category. Here is the watch order sequence diagram where the Google Maps interface is used. Here is the viewing of logs or user activity. Here is the logging of the activity that powers the viewing of the logs. Here we have the system decomposition. We exercise a client-server pattern where the application will be accessed from a Windows laptop through the Internet Explorer browser. It connects to the server through the HTTP protocol. It's a client server, but we also implement the model view controller pattern, where the view is dynamically updated by the controller, and the controller accesses the model, which is the data, to create a more efficient environment where all the logic can reside in one area. The second major pattern we applied to the project was a publish-subscribe pattern, because we will have 4 streams of data where each stream of data is a shift. The morning shift, the afternoon shift, and the night shift are each going to be a stream of data where what is put into the morning shift is not put into the night shift. Officers subscribed to the morning shift are those who are assigned to the morning shift. And the last pattern we used was the factory pattern. Because we used the Angular framework, the Angular framework includes factories which instantiate the controllers. For the system deployment, the minimum hardware we would require is 2 gigabytes of RAM, 100 megabytes of extra hard drive. This is just for the website, the PHP, JavaScript, CSS, and HTML. And we recommend a 1.5 gigahertz or higher CPU for proper functioning of the website. The software requirements include an Apache to HTTP server, Ubuntu 14.04 long-term service. You may get server edition, MySQL server, and PHP 5.5. This is our database design. It includes our account information, are file information and various other tables that enable features such as the Google Maps API. For security and privacy, the most important thing we did was for the user information, it is both salted and hashed and then encrypted using the crypto.js library, where the salting and hashing creates a unique value that is then encrypted. We use a SHA hashing algorithm to generate a unique username and password combination, and that is then encrypted, and then that encrypted data is what is stored into the server for validation later when a user tries to log in. The deployment of the web application is planned to be within the Pinecrest Police Department's VPN. So as long as the VPN has its integrity, there should be very little security risk. The minimal class diagram. Because we use the MVC pattern, you can see in the bottom half of the diagram we have the three main controllers for each module: the supervisor controller, the administrator controller, and the officer controller. And these controllers are bound to views. The views are the boundary objects which the controllers populate. The controllers talk to a singleton data request handler, which then connects to a database handler, which is a singleton object also, and that is what directly interfaces with the database and retrieves the information and passes it back to the controllers. The main algorithm. According to our product owner, the main algorithm, more like the most important algorithm, is the viewing of the PDFs or the videos, because with all the uploading and account information and all that, the project would be useless if it did not display documents to the users, which is the main user story. So the algorithm or actions included in the viewing of documents include the officer or user should be logged into the officer home view. Once they are in the officer home view, they can click a category, and once they do that, they're brought to the category view where it has all the documents that are assigned to this specific category for this user's shift. Once the user sees a document that's interesting, he or she will click it, and that will open up the document in either a native player on their Windows computer or in the PDF viewer of their internet browser. Once they return or click outside or close the PDF, it brings them back to the same category view. And from the category view, they can click the back button, and that will take them back to the home view where they can either click another category or may log out. For validation, we tested the use case of task viewing. To test this, we used PHP Unit and Selenium WebDriver. We didn't use the unit testing of PHP Unit. We used PHP Unit as a driver for the Selenium WebDriver tests. So, as you can see here, we have a simple test where we log in as a user assigned to Shift C, and we try to check a PDF which is assigned to Shift A, and then we search for that file, but the WebDriver should not be able to find it. So this test should pass if it cannot find the document which was not assigned to this user's shift. So now I will take you on a demonstration of the software. Enjoy.